Today, I want to talk about something that I have observed in computer programming. And what I have observed is part of what has held me back and part of what holds back many programmers today. See, programming used to be pretty basic. Back a long time ago, people used assembly language, and before that, they used punch cards and programmed just in binary with the programs that they were writing, which of course required knowledge of the CPU and the instruction set and all of that sort of thing. So you would think that's more complicated, right? Well, in some ways it is, but then it got better with assembly language. And then the C programming language, which is still widely used today. And I consider it really to be one of the best. C and C++ share so much of the same that I still consider them one language, although some disagree. But what has happened is modern programming languages have not really, they haven't really added anything new. As far as the computer is concerned. And what I mean is, they've added new paradigms, functional programming, object-oriented programming. They have given users new ways to do things. However, they're only new ways to do the same things, because anyone who knows much about computers knows that it's all numbers as far from a software perspective, basically. That you have RAM, you have your hard disk, that everything is a bunch of bytes, which are 8 bits of either 0 or 1. And this is something that I have become quite comfortable with, especially in my own graphics programming, because I actually have a function which creates monochrome bitmaps. I can create monochrome Windows bitmap files, and I can create the portable bitmap format, even the wireless bitmap format. My main project today is basically my binary bitmap project. I have tons of source files all in a folder. I've shown this in my previous videos, but I have some of those functions are simply outputting to formats that are not widely used, such as the wireless bitmap format and the portable pixel format, weird stuff like that. They're not used hardly ever. They can be used, mind you. If you're creating a game or something, you could have your images stored in any format you want as long as you have the code to read it. But certain image formats are only are uploadable to Facebook, Twitter, LinkedIn, all kinds of sites. So there's only 4 in common use today: BMP, GIF, JPEG, and PNG, basically. They're the main 4, even though there's over 500 formats last I checked. But a lot of my programming is done for the learning aspect. It's done because I can. So, like when I did the wireless bitmap format, it was I had to know, or with any of these monochrome bitmap formats, where a single pixel is in each bit. So a byte has 8 of the pixels of the image. It required my advanced knowledge. It required my knowledge of bit shifting, left and right shifting, and I used quite a bit of both in that code. As well as the AND or XOR bitwise operations, and that is knowledge that is not necessarily. It's known by experienced programmers, but there is a big learning curve to this sort of thing, and so I realized that it does take a lot of time to learn computer programming, to get really good at all the concepts. And there's a lot of concepts that I still don't know. I have studied some of C++. I have written my own class. I've done things involving structs before. But what I have found is that my recent discovery in my video I recorded yesterday, I discovered that my method of graphics programming turned out to be faster than using a third-party graphics library. And that's because here's what I think goes wrong in graphics programming. Because graphics programming, I will consider it my main field, because that's what I love to do the most. I like to create pictures using my programming code, and you've seen the animations that I've created. I do GIF animations. I have some of the animations on my YouTube channel. But one thing that, when I started doing my graphics programming, the way that I did it was to write my own code. And I started out with the portable bitmap format. And I used the plain text version. Would you believe there is a plain text version and there's a binary version? Well, the plain text version of binary bitmap is so easy to write. It's so easy to write, what was very interesting about it is that it consisted of basically just a text header. Like it would have the letters P1, and then it would have the width and height in numbers separated by spaces or new lines, and then it was followed by a bunch of zeros and ones in text form, so you could read it in Notepad. I would say it's the simplest of all images, because you can edit these pictures in a text editor because they're zeros and ones of text. So I started out, at the time I was writing a C++ program trying to create that very simple thing. So I had a char array, 1 byte array, and I set them to either 0 or 1. So my first checkerboard routine was written using an array of char, basically byte elements, setting them to 0 or 1 in an alternating pattern. I went on to do some cool stuff with that. So then I had a function that used printf or sprintf, whatever, or fprintf, I guess it was, because I wrote it to a file. And then I would use an external program to view the file, as I still do. I use ImageGlass as my image viewer, but there are hundreds of image viewers, so you can use whatever you like. So I basically had a program where I manipulated an array, set the exact colors I wanted to either black or white, because at that time that was all I could do. Was basically, as I call it, a binary bitmap, a bitmap containing 2 colors. And that was the inspiration for the binary bitmap project. But of course, I went on to create grayscale and full color images as well, using the portable gray map and the portable pixel format. And then I got more advanced. I started learning how to write images of other formats, and I studied the Windows bitmap format extensively. Now, the reason that I use the Windows bitmap format is not because it's the easiest to write. In fact, I have some criticisms of it, but because it is a format that pretty much every program in the world understands the Windows bitmap format. It's been supported in all Windows operating systems natively since Windows version 2.0, and so and it's you can upload it to Facebook, for example. That's another thing, is I could create a picture and then I could upload it to Facebook instantly, then delete the file. You know what I mean? So that's how I got started with my current project, and so then it was all a matter of time. But one thing, I'm rambling on here, but one thing about my project that was unique is that my previous attempts at graphics programming did not go so well. I used SDL, I used SFML, I used Allegro for various projects, little small things, but unfortunately I got so confused by the code because it's cluttered. If you've seen the Allegro code in my recent videos, you'll see what I mean. Because first you have to call a function to initialize the library, then you have to initialize the keyboard, you have to initialize the display, you have to have an event queue that receives events. And my own programming method that I've shown in other videos as well bypasses all of that, because literally all you have to do is you can do these in little steps. You can create an array of a certain number of elements. Of course, I create two-dimensional arrays, which are simulated with one-dimensional arrays. But basically, allocating the memory using malloc, or you can use a static array, and then finding a way to output that. And I started out with text because text is easy because you can see a visual representation in your console. So that was the way I started. I was able to piece together piece by piece. So there's the allocating the memory, then there's displaying what those numbers are to the console, and so it gives you a rough idea in the console. And then moving from the console to learning file input and output, which I had some experience at outputting files. In reading files, I'm not that good at, although I do have some functions that can read Windows bitmap files, for example. So moving from text to the console, to text to a file, then making heavy use of fwrite is what I started using to output the exact binary values for the binary formats. I basically was able to have an image, starting out like I would create an image, draw a single pixel. Then I learned how to, draw rectangles to it, or an easy one was filling the entire image with a solid color, So I was able to build it piece by piece because I didn't have all that extra clutter. I didn't have to call certain functions in a certain order. I didn't need to know the structs of a library. It was all just numbers. It's like, let's create an array of integers. Let's index them and set them to various numbers representing different colors. And then, writing the function that would output a file in a certain format. It's only a matter of time how much you understand that format. And then from there, I got into animation. It was very simple to do because, and this is one thing about the C programming language that I really like. And of course, it can be done with C++ as well, but it takes a lot more code to do this in C++ style code than it does to just use sprintf. The sprintf function, I can write formatted output not to a file and not to the console, but to a string. So that's how it creates the file numbers. So the way I have the files numbered in numerical order, but padded with extra zeros and then following by their extension. sprintf is easy to use. It made it possible. So I started doing things like, let's change this image slightly each time, and it got really cool. But so I did all of that. I created checkerboard animations where the checkerboard rolls, it just keeps scrolling. I did stuff with the gingham design. I even did stripes. I did a lot of stuff, and I have all the code because I back up my code like nobody else. But I did so well at making these basic animations and then creating a series of image files so I could see each individual frame in ImageGlass, what it looks like and how it differed. And then what really set it off was, in order to make put those various files into an animation file, there were two tools I used. One of them was ImageMagick, and I also used Graphics Magic as well. Both of them are very similar projects. They started out as one, but then developers disagreed. And then I also used FFmpeg to create video files. And I have commands in the make file that set this stuff up automatically for me after I have the image files. So I was able to, with all my own code, create the image files, and then I could use third-party tools outside of my program to turn those files into animations so that people could see the spinning polygons on YouTube or on Facebook. And so that's what I did. But then when I entered the world of SDL and Allegro, which I consider to be really cool libraries, I found that it was more complicated because all of a sudden everything is, a structure or a class, and you have to have a pointer to this struct, and then you have to call this function. So then it required a whole lot more work, because instead of dealing with my own code, which I wrote all the functions, except for the Bresenham line algorithm, which I stole that off of rosettacode.org, I believe it was. But pretty much all the other functions I wrote, and because I wrote them, I knew how they worked. And I was free to rename them at any time, because all of the names of them were in my own code. But when you're learning SDL or Allegro or SFML or some other type of library where you're trying to get graphics created on a screen, well, you have to know, you have to learn the API, you have to learn the names of all the functions, you have to learn, okay, what arguments does this function accept, what does it take? Whereas when I wrote my own code, it was my own code, so I knew how to run it. But then it occurred to me, somebody else who tried to use my BBM library, even if they had all the full source code, which I actually made available publicly, they would not have the knowledge on how to use it. They could experiment, but because I don't currently have a documentation for it, aside from the comments included before each function, somebody else would be as clueless with my code as I am with Allegro's code, for example. So I think the beauty of computer programming is that there are a few basics you have to learn, like the C standard library, obviously, or whatever the standard library of your programming language is. But usually, of a programming language, the standard library will be very small, or there's only a few parts you actually need to know. Most people start out with Hello World and that kind of thing. But I think, I've been programming since I was 14 years old, and I'm 30. Well, yeah, I'm 32 now. I'll be 33 May 15, and I've learned so much, and to this day I still have not created my own video game. I've made a few attempts at some things, but you never know, maybe I'll be 60 by the time I succeed in that. But I have enjoyed programming because it allowed me to build something from the ground up, basically. And that's what I like about it. And what I was explaining to my mom, who doesn't understand all my computer programming stuff, but I was explaining to her how humans can disagree over the right way to do computer programming, but the computer is the decider of whether it's valid. Basically, if your code is valid, it will compile. If your code has errors, syntax errors, it won't compile. And then when you run it, if it crashes and gives you a segmentation fault, then something's wrong. You made a mistake in your code. And you can even Google, solutions on how to fix it if you're getting a certain error, to give you clues. But basically, you're communicating with a computer. When you're computer programming, you're communicating with a computer. And in a way, programming is kind of like a game. Because just as in Minecraft, for example, I have to learn the ways to do things. Like, how do I get, this item? How do I craft it, Just as when you're learning a game, you have to learn how to do things. When you're trying to instruct a computer on things, there's a lot to learn about computers, and that's what's great. The reason people like video games, reason people like computer programming and interacting with computers and electronic devices is because they're easier. Simple fact of the matter is, I do like machines more than humans. And it's not hard to see why. They don't preach their religion at me. They don't argue with me over politics and tell me that I'm evil for being pro-life or telling me which politician to vote for. Computers don't try to have sex with me. They don't make penis jokes. Everything that humans do that I hate, computers can't do. Why? Well, they're not capable of it. And the very fact that computers are not capable of doing these evil things that humans do results in me liking machines more than humans. It's very bizarre how that is, And a lot of people will tell you that they love their non-human animals more than they do the humans in their life. People have their dog or their cat, and they say they get more unconditional love from them than they do from other humans, and I like non-human animals, obviously. That's why I'm vegan, of course, because I respect their life as much as humans, but perhaps even more so because they're innocent. You know what I mean? And don't get me wrong, a lot of non-human animals do bad things, but once again, this comes to the fact that animals in the wild have to do a lot of things to survive, including killing the other animals. But then there are a lot of animals that are complete herbivores. But the bottom line is, often the reason that, for example, I'm going to make some comparisons. The reason that that non-human animals are better than humans is because they're not capable of the type of evil that humans are. Because they're capable of less, this actually makes them better, because there's certain things they're guaranteed not to do. They're not going to, produce the pollution that the human society can. No matter how much another animal does to cause pollution, humans can cause more pollution with their industry and their automobiles and their airplanes, and then factory farming, which is obviously causing the greatest impact on climate change. But humans are capable of evil on a massive scale, and animals are not capable of that kind of massive evil. And computers are not capable of doing anything other than what they're told. So it's all in the hands of the programmers, basically. So that's what I like about it. But and I'm also going to do this comparison with programming languages. The reason that I find C to be easier than C++ is quite simply because of the fact that it contains less. Whereas one of the problems with C++, although I do know quite a bit, is that with C++ you're introduced to all these advanced concepts that you don't necessarily need. And C++ books and courses are much, much bigger because C is a smaller language. It does less. But here's the key, is that back to programming, everything that C does, everything that C++ does, and even modern languages like Python or Java or something, well, they all had to be written in C. You know what I mean? So there's nothing that can be done in C++ that couldn't be done in C. It just takes more work because all that code has to be written to do whatever your task is. And just like there's nothing that that C can do that assembly language couldn't do. What we're dealing with is that there is a certain level of base. There's a certain base level of the way computers operate, and that does not change. Programming languages fade in and out of popularity according to the number of humans who use them based on why they like them. But the reason I still use C the most to this day is because it's just so simple. Setting this variable to this number, setting this element of this array to this number. And since everything I do is numbers, since this graphics is all numbers, the colors are numbers, the coordinates are numbers, since all of that's just numbers, that is what I love. Because I like arithmetic, I like numbers, I like counting things, I'm obsessed with that. Even when I play Minecraft, the coordinates in Minecraft, and just like the coordinates in an image file, are the same concept. Every location, if you know the location, the coordinates of something, you know exactly where it is. So geometry and arithmetic. I mean, that's what the video games I play are about. That's what my computer programming is about. It's all art. And sometime I need to get back into my designing art in Inkscape that I've done a lot, because I've done videos on that before. All the art I've designed in Inkscape. I have art books on Amazon for sale that nobody buys, but I'm an artist and that's what I do. And so this has been kind of a rant about computer programming, but back to my original point that I was trying to make is that my own method, although it took a lot of work it's once I'm used to it, because I wrote the code, I know how to call each function to do what it does. And it runs faster than using another graphics library written by another person, because I have control. I can optimize it. Anything that it's doing, I can, if there's a function that seems to run slow, I can look at that function, I can optimize it. Whereas you can do the same with other people's graphics libraries, but they're not designed like mine is. See, other libraries, like all of these functions will require a structure to an SDL surface or some Allegro bitmap, for example, meaning that struct has to be defined somewhere in the code, and if you don't have that structure definition, all the other functions won't compile. Whereas my method of doing things in my binary bitmap project with C, well, they were independent pieces. Since I passed as arguments the pointers and the integers of the width and height and all of that to each function, I can remove one function from my source code, and if there's no function that calls it, obviously, then it will still compile. Whereas the same can't be said if something is in a struct or C++ class. The point is, my parts are independent, and I'll get compile errors. Like even if a function is never called in the code, if somebody removes the structure or some variable type that a certain function refers to, that function will no longer work. Whereas because I only use numbers, just integers or floating point in certain cases, for all of my variables in all my functions, they can be isolated. It's possible to isolate certain functions to create smaller executable files and all kinds of stuff, and smaller source files. So if I create a certain animation that I want to publish, and I want people to be able to look at the source code and modify it, I don't need to copy every single function from my BBM library, because it's actually huge, because I've worked on it for over a year. I only need to copy over the functions that are actually called by the function that's doing the animation. So the fact that my code is split into modules or independent parts is one of the things that makes it beautiful. So yeah, my code is just great, and it's freaky. All the stuff I've been able to do with it, I'm just amazed at the animations I've been able to do. And even if I never get beyond spinning polygons, I'm quite impressed with the fact that I was even able to do that. So anyway, that's my rant for right now. I'm just so excited about computer programming and the things I've been doing that I had to record another video.